This is the 1-1B lesson, adding and subtracting integers. Integers are whole numbers and their opposites. We're going to list them out. We use these kind of crazy looking little curly things called braces that are not parentheses and not brackets. And we're going to do dot, 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 meaning that this list goes on forever in both directions. -3, -2, -1, 0, 1, 2, 3, dot, dot, dot. And there is our sample of what, or our set list of integers. No fractions or decimals unless they simplify down to these numbers. So negative numbers, positive numbers, and zero. Zero pairs are a pair of numbers that, when added together, equal zero. We'll list out a couple of examples. So that would be -1 plus 1 would cancel out to be 0. And we're going to review how to add integers in just a minute. I'll think of some easier ones though. 2 plus -2 is 0. So when we add two numbers up and they equal 0, then those two numbers must have been what is called a zero pair. They cancel out into 0. Next, it says use the rules for adding integers to complete the table below. Apply zero pairs when applicable. So we're going to use this table as a way to also remember what is the rule for adding integers. So 6 plus -2 has been chipped or tiled for us. We have 6 positive. They're not shaded. So these ones represent that. And we have -2, which is 2 shaded, which are those. And what we're going to do is we're going to cancel zero pairs, die, cancel those off. And we're left with 4. In a minute, we'll come back and try to figure out what is the strategy to know that without having to draw out the chips or tiles. But it's also a good idea to do that if you forget something. That's probably one of the best ways to do these problems. Next, we're going to make an addition statement. This would be -4 plus 1, 2, 3, 4, 5, 6, 7. Or you could do 7 plus -4. So watch out for this shading. That means it's negative. And we're going to cross off zero pairs. Those cancel. Those cancel. This one will cancel with this one. It doesn't matter which ones you cancel as long as it's one shaded and one unshaded. And those cancel, and we're left with 3. +3 because they're not shaded. Next, we're going to tile or do this one. Do 5 that are shaded. One more that is shaded. Doesn't matter how you lay these out. None of them cancel, so count them up. I have 6 and they're shaded, so it is -6. 3 unshaded. 9 shaded. And I like to do a 3x3 grid for the shaded ones and then 3 unshaded, just so that I keep track of them. This one cancels with that. There's another pair and another pair. And we are left with -6 again. Cool. All right, so what do we see from this? Because in a minute, we're going to stop doing the chips or tiles. By the way, if you have a question about how to do problems, it's probably best to do these for a little bit. But let's kind of recap. On number 3, it came out to be positive. We had competing signs, so we had to cancel, die, cancel tiles. In 6, won out because it was more dominant or more powerful, right? There was more of those. We also had tiles kind of die off on number 4, and 7 was more dominant. So it came out to be positive. So there were still, it's like a battle royale. The positives were left. When we had two negatives, it stayed negative because there weren't any zero pairs. In this one, the last one, 6, -9 was more dominant. And I say more dominant and not bigger because we shouldn't really say that -9 is bigger because it's technically smaller, but it still wins out, right? It's like a battle, and there's the shaded ones left over, which gets us a -6. So as we do problems, you can tile them. Another way is maybe just to mark somehow, like with a squiggly line or something, which one appears to be more powerful or dominant to help you predict whether it's positive or negative.